Hello, today we are going to look at a type of graph called a bar chart, and this helps us with drawing out data where the numbers are larger. So line plots require us to draw individual dots for each instance of something. Whenever the frequency gets bigger, we have to draw an extra dot. If we had numbers that went into the tens or the hundreds or the thousands, we'd be drawing hundreds or thousands of dots, and that would become extremely cumbersome and unhelpful. So we can switch to bar charts when the numbers get larger, and that is what we are going to look at now. So this is our justification, our setup. We have stood on a road and we have recorded the colors of the cars passing us, we'll say for an hour. And in this instance, we'll say that there were just three colors of car that passed us. We're going to have red cars, green cars, and blue cars. And this is our tally of the cars that passed us while we were standing doing our experiment by the roadside. So our job here is first going to be turning a tally into our frequency. How many red cars, how many green cars, how many blue cars did we see? And part one is we're asked to draw the bar chart, and the table is always how we are going to get our information on how to draw our bar chart. We're going to look at the specifics of it. You can see it written out here, but we're going to look at the structure of the bar chart in a moment. First of all, we need to get our frequencies. So we know that tallies give us bundles of 5, and it's an awful lot more convenient for counting up numbers when we're doing an experiment. So we have 5, 5, 5, and 3. So we have 5, 10, 15, and 18 red cars in total. So 18 red cars passed us while we were doing the experiment. In green cars, we have 5 and 5 and 4. So we have 5, 10, and 14 green cars that passed us, and we have 5, 5, 5, and 3. So 5, 10, 15, and 3 is 18 blue cars that passed us during the experiment. So that's all of the cars that passed us during the experiment. They were either red, green, or blue. So how our bar chart works is that we are going to give the bar chart a title, just like we do for all of our charts. We're going to have the frequency, how many cars in this case we saw, but it can be whatever frequency we're working with, how many cars we saw on the y-axis, the up and down axis, and our different categories. In this case, our different colors of car are going to go along the horizontal axis, along the x-axis. And I have labeled my axes, and I have labeled each one of my bars effectively that I'm going to draw in here. Now, when I look to my frequency, I have to figure out what I have to count up in. If I try to count up in ones, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have enough space. I could just draw this bigger, but at a certain point I have to get more creative with what I count up in my numbers. So look to the frequency that you've got and see what you want to count up in order to have a reasonable sized graph. We want nice big graphs, but sometimes we will have to pick the numbers we count up in order to have them fit on our page. So in this case, I could see that I have 10 boxes to work with, and my highest number is 18. So I'm going to count up in twos so that I'm going to get up to 20 up here, and then I'm going to have a nice big graph, and it's also going to fit to my page. So I'm going to write those numbers in and come back to you. So we have our numbers drawn in here, and we're always going to start down at 0 with our bar chart. So 0 is down here, and then we've gone up in twos up to 20, and that covers our frequency that we need. Remember, we always count frequency on the up and down axis, the y-axis. So the way a bar chart works is fairly sensibly that we draw bars. So I've drawn the base of my bars here. So the base of the red bar here is these two dashes that I've put in. And I'm going to draw a bar that goes up to 18. So I'm going to go up to 18 and across and down. And that's going to give me the bar for my red bar in my from my frequency. and I'm going to draw that in now. We use a ruler to draw that, and you can see that there's a gap between the beginning of my red bar, and there's a gap between the red and the green bar. So there's gaps in between each of our bars in a bar chart. If there isn't, we lose huge marks. So we want to make sure there's a gap between each one of our bars, and we're using the grid on our pages in order to draw in our bars very neat and accurately. These diagrams, these bar charts, just like the line plots, are supposed to help us visualize our data. We have lots of numbers going on here, but a picture helps us see it very clearly. If we don't do it neatly, we aren't able to see our data properly, so we don't get any marks for our work. So these charts need to be very tidy, very neat, following all of our straight lines in order for us to get marks for them, because their purpose is to be clear so that we can see our data more easily. So I'm going to draw in my red bar now. So I have my red bar drawn in here with my ruler, nice straight lines, and I'm following the grid lines in my copy so that everything is very neat and kept exactly where it needs to be. And again, there's a gap between my y-axis, my frequency axis, and the red bar, and there's going to be a gap now to my green bar, and then another gap to my blue bar. So my bar, I define the base of it here by putting in my little dashes. I've made my bars 2 boxes wide, and the gaps in between are 1 box wide. And then I'm going to go up to 18. So this tells me that there are 18 red cars. If I was asked about this and I had my red cars, there would be 18 red cars because my bar goes up to 18. So now I'm going to draw in my green bar and my blue bar. So I have my 3 bars now drawn in, and I can see immediately from this that my green one is the least often seen type of color, and I can see that I get the same number of red and blue. Now with this fairly small number of data points like we've got here, you can probably see that from the table, and tables are a very good way of seeing data as well. But if we had a big amount of data where we had a long list of different options, this picture will give us a much stronger feel for what's the most frequently seen type of color, what's the most common type of color, and so on. So this is how we draw our bar chart: frequency on the up and down axis, and our different categories, in this case our different colors, on the x-axis, the side-to-side axis. A gap in between each bar, and then our bars rising up using our rulers up to the frequencies that we need for each bar, and keep each bar the same thickness as well. I've used 2 squares here for the thickness of each box. And again, consistency is what gets us marks with these types of questions. Now let's go on to our next bunch of questions here. The total number of cars. Well, we have a frequency table drawn here, so that's very easy. We just add up the frequencies. If we saw 18 red cars, 14 green cars, and 18 blue cars, to find the total number of cars, we just add 18, 14, and 18. That's all of the cars that we saw. So we just add up our different frequencies in order to find the total number of cars. And when we do that, we get 50 cars. So there were a total of 50 cars that passed us when we were doing our experiment. So that's our total number, and that's a fairly common type of question, or the basis of a fairly common type of question. The modal color. We know that mode is one of our measures of center, is one of our measures of average, and it means most seen. So mode is most seen, and it can also be called modal, is another way of asking for the mode. Well, in this case, we have 2 modes. We have red and blue are the modal colors. They have the same frequency, and they're both the highest frequency. So red and blue. Next one, what fraction of the cars are green? Well, often in these types of questions, they will give us a helping hand and get us to get the total first. But if we want to know the fraction of cars that are green, we will get the number of green cars out of the total number of cars. So even if they didn't give us this earlier in the question, we'd know that the fraction of cars that would be green would be the number of green cars out of the total number of cars. So in this case, we're going to have 14 green cars out of 50 cars. And then we look for a highest common factor top and bottom. We can put it into our calculator, but again, looking for highest common factors and so on is important. So there's a common factor of 2 top and bottom, so we can divide above and below by 2. We can divide above and below by 2. There's a few different ways of writing that. We could put in a dash in between them as well. A dash across them, I should say, and we would end up with 7 all over 25. It's important that we are constantly training ourselves in looking for these types of patterns because they are so important in more advanced maths. But this is our fraction of cars that would be green, 7 out of 25. And that's just because we always want to simplify fractions if we can. Now, what's the percentage of cars that are red? So percentage of cars that are red, a percentage is where we have a fraction out of 100. So the percentage of cars that are red, we go to the number of red cars, it's going to be 18 out of 50. But we want to know the percentage out of 100. So per cent means per 100. Cent as in the cent in, there's 100 cent in a euro. So we need to get the denominator here equal to 100. We're at 50. What do we need to do? Well, we need to multiply above and below by 2. And we need to multiply A on the top by 2 to keep our fraction the same. If we make both sides, both top and bottom, twice as big, we haven't changed our fraction. So we get 36 out of 100, which we would write as 36 per cent. So per cent means per 100. Another way of doing this problem, particularly if the fraction wasn't as easy to work out, would be if we have 18 out of 50, we can use a rule type method. If we take this fraction and multiply it on our calculators by 100 over 1, we will end up getting 36% as well. And it's important that we know this method because we won't always be able to do this. We should always aim to figure out the pattern to get a denominator of 100. But if it's an unpleasant fraction or an awkward decimal, we need to know that putting in our fraction into the calculator and multiplying it by 100 will also give us our percentage. And it's important we know both methods. So that is what we need.